Hi all, and welcome to Statics with Jeff. I'm here to show you some key concepts that you'll cover in a first semester vector mechanics class in your regular engineering curriculum. The main thing that we'll deal with in statics and other engineering classes too is vectors. We know that a vector, this guy right here, is a vector, is something with magnitude and direction. And for a lot of these engineering courses, and especially statics, you'll deal with ones that are like weight or tension. So if this guy right here is a vector, let me say he's got 5 newtons of magnitude, we need some sort of coordinate system to base his direction off of. So let's use, since we need that coordinate system, let's use something that we're familiar with, an X and Y Cartesian plane, with the X being at 90 degrees to the Y, which will get important in a second here. But we've got our coordinate plane and we've got our vector in it. So how about now we define an angle that vector is in reference to the X plane, to that X axis right there. So we say that this vector is at 30 degrees to the X axis. That gives us a direction. Now if we want to use this vector to help us solve equations, engineering applications, the easiest way to take care of it is if we have it split into 2 components. One in the Y, a vertical component, and one in the X, a horizontal component. Now to do this, we need to think back to our trigonometry, because we'll be dealing with angles and side lengths. We think of the magnitude of these vectors as the length of the side of this triangle. And since that X and the Y, the X and the Y are perpendicular to each other, then we say that these 2 vectors are also perpendicular to each other. That gives us access to some cool properties which we can utilize with our trig identities. So our sine of some angle theta, which is the opposite over the hypotenuse of a triangle. Get that H on there. And then the cosine of some angle theta, which is the adjacent leg over the hypotenuse of that triangle, and then the tangent of theta. Tangent of theta, which is the opposite over the adjacent leg. Mainly today we'll deal with these 2 right here, because say that we're trying to define what this force in the Y direction is. Well, we have a hypotenuse, we have our angle theta right there, which this case is 30 degrees, and we want that opposite leg to theta. So we look over at our trig identities and we see there's our theta, there's our hypotenuse. How about, since we want that opposite, that we multiply both sides by the hypotenuse, which would cancel it out from this side here, and have it multiplied over here, and that would give us our opposite leg from our hypotenuse times our sine of theta. So now we do that same thing with our force. So our hypotenuse in this case, is 5 newtons multiplied by the sine of our angle theta at 30 degrees, which we know from our trig that sine of 30 degrees is 1/2. So 1/2 of 5 is 2.5. 2.5 newtons for our y component. Now we want to do the same thing with this x component. So again, we look over here and we see, oh well, we have an adjacent leg that we're looking for, and we know what our theta is and our hypotenuse is. And we look here and see there's our theta, there's hypotenuse. We want adjacent, so we multiply both sides by the hypotenuse again. And that cancels it off on the adjacent side and brings it over right next to cosine. We can do the same thing down here, just like we did with the y component, except now we're using cosine for that x component. And there's 5 newton times cosine of 30 degrees. And we know that cosine of 30 degrees is root 3 over 2. So since it's over 2, we'll divide that 5 by half. We get 2.5 times root 3 newtons in that x direction. And this has effectively broken down our main 5 Newton force into 2 perpendicular components, one horizontal, the x, one vertical, which allows us to add to other forces components. If we had another force over here, we broke down those components, we could add them to this a lot easier than we could this one going up at an odd angle. But that'll come in another video. This is a good concept to understand. You want to go back and make sure you know your trig identities really well, because you'll use them a lot in statics. Before I go, I have 2 recommendations for you, 2 websites. We have khanacademy.org, great place for math, physics, science, history videos, but specifically he has a couple playlists on vectors and also on trigonometry, both which would be really helpful to review. The other website is statics.com. You go to this website and the guy has a whole bunch of videos with specific problems in statics that he's worked through and made videos of. They'd be great for you to watch and review in case you have more specific questions. But until then, keep up on your practice, keep having fun, and I'll see you soon.